start the recording, go back to sharing. And so once again, we have this that needs to be at the beginning of the recording. The idea that if you don't want to be made public, keep your video off and use a different name. Anyway, all right, so today, eventually, we're going to get to section 4.5. But first of all, we're going to answer some questions from yesterday from section 3.7. I'm going to start with two specific questions because I had two different individuals email these two problems to me. So I'm going to start off with those, and then I'll open up for other questions as well. And these are from WebAssign, number 15 and number 19. And I want to point out that you may not all have had the exact same numbers in the problems. They will be the same kinds of problems, but the one that I'm doing may or may not be the same numbers that you had. So just to keep that in mind. Okay, so let's see here. Get my act together. Come down here. All right, so the first problem, and I'm going to do some work and then I'll go to WebAssign, but the first problem was 9x minus 9y is greater than or equal to negative 11. Now, I'm going to use the slope-intercept method. If you want me to go back and do it a different way using specific points, ordered pairs, let me know. I'm happy to do that at no extra charge to you or your family. All right, so I'm going to solve this thing for y. So the first thing I'm going to do is subtract 9x from both sides of the inequality. That gives me negative 9y greater than or equal to negative 9x minus 11. As I'm going along, if you have any questions, feel free to stop me and say, hey, wait a minute, what's happening there? Okay. Next step, I'm going to divide each term on both sides of the inequality by negative 9. What that does, it isolates y, but because I divided both sides by a negative number, we're going to change the direction of the inequality sign. Negative 9 divided by negative 9 is 1, so I get 1x. Negative 11 over negative 9 would be a positive 11 ninths. All right, now, this says y is less than or equal to x plus 11 ninths. So we're including the equal to, we're including the solid line y equals x plus 11 ninths. So what we've got here is we've got a slope of 1 because the coefficient of x is 1 and a y-intercept of 11 ninths. And my suspicion is that's where the problem came in. All right, so I'm going to take that information and I'm going to stop sharing and go back and share. Can you now see WebAssign on your screen?
Yes.
Okay, great. So we're going to look at problem number 15. Now recall the information I have. It has a slope of 1 and a y-intercept of 11 ninths. So I need to graph a solid line because it's equal to as well as greater than. So I'm going to go over here to the solid line and click on it until it turns blue. Okay. Now the y-intercept was 11 ninths. So that means I'm going to have a point at 0, 11 ninths. Now 11 ninths is a little bit more than 1. But the problem is when I go and click right there, it just kind of drug that point to 1. Don't panic, I'm going to fix it. Now, the slope is 1, so that means it goes up 1 and over 1. So there we go. Now, neither one of those points are correct. However, I'm going to go over here where it says line and click on line 1. My first ordered pair was 0, 11 ninths. So I'm going to delete the 1 and put an 11 backslash 9. Okay. Now, my second point also is not correct because I found it by just going up 1 and over 1. So using the slope in this case is going to make it difficult for me to get that second ordered pair. So I'm going to go back to this screen. Okay, so you can see where I've got a slope of 1 and a y-intercept of 11/9. Okay, if I take y equals x plus 11/9, and x is 0, y is 11/9. What if x is 1? Y would be 1 plus 11/9. 1 plus 11/9 is 9/9 plus 11/9, which is 20/9. So in this case, I ended up actually using 2 ordered pairs anyway. I started out finding the slope and all that, but so my second point needs to be 1, 20/9. Before I go back to the WebAssign screen, are there any questions how I got that second ordered pair? Okay, so now I'm going to stop sharing that and go back to the WebAssign screen. I'm going to go to my second point right here. So my x value is 1 and my y value is 20/9. Now my line has been moved, as you saw when I changed the coordinates. Okay, so there's my line, and it said y was less than or equal to x plus 11/9. So the equal to part is the solid line. Y is less than or equal to. So where would y be less than this line? Y would be below it. So I'm going to fill. This always pops up whenever I click that, just telling me I need to do that last. So okay, I'm going to fill that in right there and then submit my answer. And there you go. All right. Anyone present that wants to speak? Are there any questions about what I did there? Any part of that problem that was confusing to you?
I had one question.
Yes.
I know you kind of explained some of this yesterday, but I've just been having a little bit of difficulty doing it.
Sure.
Is the y-intercept always the one on the right of the comparison sign?
Okay, let me go back.
Whereas like
here.
the slope is next to the x variable?
Yeah, so y equals mx plus b, when it's in that form, which is what this is, if you thought of it just as the equal sign, the m is the coefficient of x, yes, and the constant term out at the right is the y-intercept. That is correct.
Okay.
All right. Any other? You bet. Any other questions back here on the WebAssign problem? All right. Let's take a look at problem number 19, which is this one here. So we've got x minus 1.2 less than or equal to 0. Okay. X minus 1.2 less than or equal to 0. Okay. So this doesn't have both x and y. It just has one variable. So we're going to solve for that one variable by adding 1.2 to both sides of the inequality. Now, we talked about this yesterday, and I'll remind you, if you have an equation that's x equals some number, that's going to be a vertical line. If you've got y equals some number, that's going to be a horizontal line. Okay. So this, we're going to start out with a vertical line where x, let's see, x is going to be 1.2. What is y? Y isn't even in the inequality, so y can take on any value at once, and we still have an x equals 1.2. All right, so now let's go back to the WebAssign screen. And again, we're going to click on this to get it blue. So x is 1.2. Y can be anything at once. Okay, well, if x is 1.2, y could be 0. If x is 1.2, y could be 3. Now, once again, when I tried to click on x being 1.2, WebAssign drug that point over to a nice value. So I'm going to come back here. Let's see. I need my x value to be 1.2 when y is 0. I need my x value to be 1.2 when y is 3. Any questions about how I did that? Now, my inequality was x is less than or equal to 1.2. Since it includes the equal to, I'm going to leave this line solid. Where is x less than 1.2? On the left side of the graph. So I'm going to fill it on the left side and then submit it. And there you have it. Any questions about any part of this problem that we just went over? Okay. So, do any of you that wish to ask have any other questions from your WebAssign assignment last night? While I've got this open, we can look at others if you want.
Yes.
What do you want to look at, Gabriel?
14.
14. Okay. Alrighty. So let's see here. I'm going to stop sharing that. Again, go back to this screen. And we've got 4x plus y greater than or equal to -4. Is it okay if I use the slope-intercept method, or do you want me to find ordered pairs?
Whichever. It doesn't
Okay,
matter.
so I'm going to solve this inequality for y. I will subtract 4x from both sides of the inequality, giving me y greater than or equal to -4x minus 4. Okay, I didn't multiply or divide by a negative, so I didn't change the direction of the inequality sign. If we consider the equals part, y equals -4x minus 4, our slope is -4, and our y-intercept is also -4. Any question about where I got those two numbers? Okay, so using this information, we're going to go back to the WebAssign screen. And I'm going to get that to turn blue. So my y-intercept is at -4, which is right there. We've got nice numbers for this problem, so that's good. We aren't going to have to adjust our ordered pairs. The slope is -4, so going from left to right, I'm going to go down 4 as I go over 1. Okay. Any questions about that?
No.
All right. Now, it said y is greater than or equal to -4x minus 4. So the solid line represents the equal to part. Y is greater than would be above the line, which is over here. So fill, click it on that side, and submit the answer. Yay! All right with that?
Yeah.
Any part of that problem any of you want me to go over again?
I had one question about it.
Yes.
So when I did it, or when I was doing the linear equation part, I had taken 4, maybe I didn't, or I probably didn't do this right, but I took 4x and then subtracted 4x from that on the left side. And so how do you know the first one is -4?
Okay, all right, let's go back to this screen. So did you get it in this form that I'm circling?
No.
Well, you said you subtracted 4x from both sides, right?
I did.
So what did you get when you subtracted 4x from both sides?
got negative 8x because of the two
Oh, wait, okay,
negative 4.
okay, I think I see what you did. So you took -4 and -4x and made it -8x, right?
Yes.
Okay, these two terms are what we say they're not like terms, so you
Oh, okay.
can't combine them. If it had been -4x minus 4 more x, that would be -8x. But we've got a term with x and a constant term.
Okay.
That makes sense?
Yes, thank you.
So that's how we got here. And then from there, there's your slope and there's your y-intercept. Okay?
So the slope is 4x and the y-intercept
The
is...
slope is -4.
Okay.
So this y equals mx plus b. When I solve for y on the left, then my coefficient of x is the slope. It's like -4/1, so you're going to go down 4/1. And then the y-intercept would be at -4. Because if x is 0, this term disappears and all you've got left is the constant term.
Okay, thank you.
You sure? Okay with that?
I think so, yeah.
Okay. Any other questions concerning any of the problems?
Number 12.
Sorry?
12.
Number 12. Okay. Let's take a look at number 12. And so here we go. There's number 12, which says 9x minus 2y is greater than 6. Okay, so I'm going to take that and go back here. Is anybody getting dizzy from me changing back and forth on these screens? Maybe I'm the only one. All right, so 9x minus 2y greater than 6. Do you want me to use slope-intercept form or the other form?
Hold on. It doesn't matter. The
Doesn't
slope.
matter. Okay, all right. So I'm going to subtract 9x from both sides, giving me -2y greater than -9x plus 6. I'm going to divide each term on both sides of the inequality by a -2. I get y. Since I divided by a negative, I changed the direction of the inequality sign. -9 over -2 is positive 9/2 times x, plus 6 over -2 is going to be -3. Any questions there? So now my slope is going to be 9/2, and my y-intercept is going to be -3. Just a matter of review. Those of you that want to do some review on your own, it's like the whole idea of slope-intercept. It's like, what's going on there? You know, feel free to ask me or come to my office hour Zoom session. But if you want to just look in the book, chapter 3 talks about all of this. In fact, let's see, it's 3.5 is where the idea of slope-intercept form is introduced. So if you wanted to do some review on your own with that concept, that's where you'd find it. Anyway, okay, so I've got a slope of 9/2 and a y-intercept of -3. And now let's go back to WebAssign. I'm going to turn that blue. So I'm going to start at -3. So 0, -3. My slope is 9/2. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 2. All right. Now, my inequality was y is less than 9/2 x minus 3. It did not include an equal sign, so I need to make this line dotted. So I go over here to the line 1 and click on it and choose, or dashed. I keep saying dotted, dotted, dashed, same thing, I guess. So now I've got my dotted line, my dashed line. but it said y is less than. So less than would be below this line. So is it over here on the left or over on the right? Where is below the line? If we start on a point of the line and we go below, wouldn't that be on the right side?
Yeah, the right.
Okay, so I'm going to fill on the right side. And there we go. All right with that?
Yes, thank you.
What was that?
Thank you.
Okay, I thought somebody was asking for number 2, but they're just describing something. Okay, any other questions from last night's assignment?
So I actually have a different number 12 that I'm struggling.
What? Okay. Let's see here. Okay. So what is it?
It is 9x minus 7y is greater than 21.
Okay. So we would subtract 9x from both sides of the equation, or the inequality, excuse me. Negative 7y is greater than negative 9x plus 21. Okay. Then we're going to divide everybody by negative 7. So y is less than 9/7 x minus 3. Okay with that?
Yep.
Now, the slope is 9/7 and the y-intercept is negative 3. Okay, here's what I'm going to do. So hopefully you won't get confused by this. I'm going to go ahead and graph it on here. I'm not going to click to submit it because it would be wrong according to that. But I'm just going to show you what it should look like. Okay? So we'll clear it out. I had a y-intercept of negative 3. So that would be right there. The slope is 9/7. So I'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3, 4, 5, 6, 7. Okay. It was y is less than. So I'm going to make it a dashed line. I said dashed. Are you proud of me? Okay. It says y is less than. So filling it would be right there. Now, again, I'm not going to click submit because if I do, it's going to say it's wrong because I'm not doing this problem up here. I'm doing the one you gave me. But do you see how that works?
Yes.
Any questions about that?
Well, I did that in here on the homework, and it is saying that it's wrong.
Okay, let me ask you this. Well, actually, do you want to share yours or not?
That might be a little hard because I've got
That's okay. You don't have to. Okay, just let me give you some things to check that you might have done incorrectly, and then if we still can't resolve it, maybe I'll look at it with you outside of class, and we can go in and look specifically. But some things to check on. First of all, are your ordered pairs what I've got there?
0, -3, and 7, 6.
Did you make the line dashed?
The line is dashed, yes.
And did you shade the right side?
Yeah. Okay. So mine was 7, 9.
7, 9.
Yeah.
So,
So
you had your slope as 7/9?
yeah.
Ah, okay. So let's go back and take a look at how I got the 9/7. Okay, so moving the 9x or subtracting 9x gave me this over here, then dividing everybody by the -7, that's where we got that. So you had that upside down.
Oh, okay.
All righty?
Yeah, thank you.
You betcha. You betcha. All right. Anything else before we go on to section, what is it, 4.5 today? Okay. So let's see here. I'm going to minimize that for a moment.
Mr. Mayo,
Yes.
do you mind just kind of explaining one more time? I know you had it in your video, but just I know you tried to do the slope-intercept form. Can you just explain one more time how you go from what you have on your screen to the m equals 9/7 and then b equals -3?
Okay. And actually, I'm putting this back up, but I have a feeling that what you want to see is this stuff, right? It's this that you're talking about?
Yes.
Okay, so your question is how I'm getting from there to there?
Correct.
All right, let's just take some random problems and do this. Let's say I've got 4x minus 6y greater than or equal to 2, okay? What I'm trying to do is I'm trying to get the inequality. Of course, this sign, I don't know what it's going to be yet, but I want to isolate y on the left side, okay? When I do that, my x term comes first on the right side. Whatever the coefficient of it is the slope. This constant out here is the y-intercept. And let me show you how that's going to work. So taking this inequality, I'm going to solve for y. So I'm going to subtract 4x from both sides of the inequality. Are you okay with that?
Yes.
So I've isolated the y term. Now I need to go back and get rid of its coefficient. So since it's -6y, I divide by -6. But whatever I do on one side of the inequality, I have to do to each term on the other side.
Oh, okay.
So far, so good?
Yeah.
So -6 over -6 reduces down to 1. 1 times y is y. Since I divided by a negative number, I'm going to change the direction of the inequality sign. -4 over -6, negative divided by negative is positive, and 4/6 could be reduced to 2/3. And then +2 over -6 is going to be negative. 2/6 reduces to 1/3. So now it's in this form. Okay, so the coefficient of x is 2/3. So the slope would be 2/3. The y-intercept, when we use the letter b to represent the y-intercept, is going to be -1/3. Now, how do you find a y-intercept? You set x equal to 0. If x is 0, y, if I put 0x minus 1/3, wouldn't I just have this constant left? So that's why when it's in this form, that is always going to be your y-intercept. Because if x is 0, that term goes away, and you're left with the constant. Does that make sense?
Yeah, I just wanted a quick refresher just to take steps one more time. Thank you.
I made a deal with the school. I don't get a salary. I work on commission. They pay me so much for every problem that I work out. So really, the more questions you ask, the more money I make.
Got it.
Yeah. Or actually, I just get cookies and milk, but that's okay. It keeps me going.
Thank you so much.
You bet. We're going to go on to section 4.5. So let me see here. What do I want to do? I want to open a student view and pick that. And section 4.5. Okay, so now I've got that open. And now let's go back here. And let's see what I actually want to do. This is going to get confusing here. Let's see. I know what I'm going to do. Okay, I'm going to get out of WebAssign and we're going to open up this view. Don't panic if you can't see what I'm doing yet. Okay, so now can you all see the graphing grid?
Yes.
Okay.
Yeah.
Good, good, good. Thanks. Just want to make sure I'm pushing the right buttons. Okay. So I'm just trying to think, those of you that took beginning algebra, Math 85, I believe part of your assignments, you learned how to graph a linear equation, and then you learned how to solve a system of linear equations by graphing two separate straight lines on the same grid. And they either intersected at a single point, and that point then was the solution to the system, or the two lines were in fact the same line, so there was an infinite number of solutions, or the two lines were parallel and there was no solution. Does anybody remember doing that?
Yes.
Yeah.
Okay, one of you, great, I'm happy. Okay, we're going to do the same thing with linear inequalities. We're going to have a system of two separate linear inequalities. We're going to graph both of them on the same grid and then find out where those two intersect, and that will be the solution. So we're going to start off with a problem here where our first inequality is 2x plus y is greater than or equal to 3. Let me see if I can do a little bit better job of that. You just never know, maybe. Okay. And then our second inequality, which I'm going to do in red, is x minus 2y less than or equal to -1. Okay, so I'm going to go through and do the same techniques that we did yesterday to graph 2x plus y greater than or equal to 3. And I'm going to graph that in black over here on the right side. Then I'm going to start over and graph the red inequality as well. Okay, so basically at this point I'm doing the same thing we did yesterday, but 2 different times. So let's go back to the black. I'm going to subtract 2x from both sides of the inequality. So that gives me y greater than or equal to -2x plus 3. Okay, now this is in slope-intercept form. My slope is -2 and my y-intercept is 3. So over on the right side, I'm going to start with a y-intercept of 3, and I'm going to go down 2 and over 1, down 2 and over 1, down 2 and over 1, etc., etc. Okay. Now, because this is greater than or equal to, I want my line to be solid. Okay. So I've got a solid line, but it says over here, after I solve for y, y is greater than or equal to, so I'm talking above the line. Okay. So if I was just doing the black inequality, that's what it would look like. Any questions there? All right, now I'm going to go back and I'm going to do the same thing with the red inequality. I'm going to solve it for y. So I'm going to subtract x from both sides. -2y less than or equal to -x minus 1. I'm going to divide each term on both sides of the inequality by a -2. So now I get y. Oh, I divided by a negative, so change the direction of the inequality sign. Don't forget there's an implied 1. So it's -1x over -2. Negative over negative is positive. So I end up getting 1/2 x. And then -1 divided by -2 would be +1/2. So the slope is 1/2. And in this case, the y-intercept is also 1/2. That's going to make things a little bit tricky, but we're okay. Any questions yet?
I have a question. So for like example on the first one, I see that you didn't do anything for like a test point. Is that because you're doing the slope-intercept form?
That is correct. You certainly could do a test point even using slope-intercept form. But the whole advantage to slope-intercept form is that then this tells you whether it's above or below. But yeah, you certainly could. Do you want me to do that?
No, I was just asking because I didn't do it that way. I did it the other way.
Fine, and we can do it the other way. You ask, I'll do it. I'll jump through hoops and gargle peanut butter if it'll help you. All right. All right, so now I've got a y-intercept of 1/2, and my slope is 1/2. So I'm going to go up 1 and over 2. But since I'm starting at 1/2, I'm going to put on my glasses here. I'm going to go up 1, which is roughly there, and then over 2, which is going to be about there. I'm going to go up 1 and over 2 is about there. And let's see, up 1 and over 2 is about there. Now, it's y is greater than or equal to. So again, I want a straight line passing through those points. Okay. But it says, what does it say? It says y is greater than or equal to, so we're talking above. All right. So now, the black is the solution to the first inequality. The red is the solution to the second inequality. The solution to the entire system is where the black and the red overlap. And I'm going to make those green. So that would be everything. So it's above this and above that, and then going on forever out in that direction. All right, how are we doing?
This makes sense.
Okay, any questions on this example?
I just have one question. So
Yes.
that is the other form, the opposite of, or I mean, the alternate form to slope-intercept form?
No, this is slope-intercept.
Oh, would you be able to do the other one?
Sure.
Okay.
Sure. Do you want me to do this same problem?
Really any problem. I just didn't remember exactly how we did the other one.
Okay. Let's see here. Let me do a new one. Okay. And let's see, we're going to go back to black here, and we've got x minus y less than or equal to 6, and then red, x plus 2y less than or equal to 6. Okay, that's a sad looking plus sign. It's still a sad looking plus sign. I had a 6th grade teacher that when you took a spelling test, if you wrote over a letter in a word, it was always wrong. And so I always think of that when I do this. She's still haunting me after all these years. Let's see. Where did I get that one from? Plus 2y. Okay. So let's go back to the black. So I'm going to consider the equation. Okay. And I'm going to complete two ordered pairs. Now, I can pick any x's, I can pick any y's, but I think I'm going to use the intercepts, okay? So I'm going to find the x-intercept by setting y equal to 0, and find the y-intercept by setting x equal to 0. So I'm going to complete these two ordered pairs, okay? So if y is 0, again, I'm focusing on the equation. We'll get back to the inequality once we start graphing. X minus y equals 6. If y is 0, I've got x minus 0 is 6, so x is 6. So there's 1 point on the graph. 6, 0. So far, so good?
Yes.
All right. If x is 0, I get 0 minus y equals 6. So I get negative y equals 6. Divide both sides by -1, y equals -6. So 0, -6. Okay. Now, I go back and look at the actual inequality. It says x minus y is less than or equal to. Since it includes the equal to, I'm going to draw a straight line through those 2 points. Okay. So it's going to be solid, not dotted, because it includes the equal to. Now, I need to use a test point. Since I haven't solved it for y, I don't know immediately which side of the line it's on, so I need to use a test point. I need to pick a point that's not on the line. If 0, 0 is not on the line, that's always a good test point. So I'm going to pick 0, 0. So if I plug 0, 0 into that, I get 0 minus 0 less than or equal to 6. Is 0 less than or equal to 6?
Yes.
So this point is good, which means the entire side is good. Okay? And if you're not convinced, pick a point over here, plug it in, you'll see that it doesn't work. For the sake of time, I'm not going to do that, but you could. Okay?
Okay.
Now
So how did you get the 2y?
This over here?
Yes.
That's the second inequality. That's a whole different inequality.
Oh, I see. Okay.
Yeah, so now we're going to do that one. I'm going to subtract x, 2y less than or equal to negative x plus 6. Oops, I'm putting it in slope-intercept. Sorry. That's just the method I prefer, so I just automatically go there. So forget that. X plus 2y equals 6. Okay? And again, we'll find a couple of ordered pairs. If y is 0, we get x plus 2 times 0 equals 6. X equals 6. Okay? If x is 0, we get 0 plus 2y equals 6. 2y equals 6. Y equals 3. Okay, so far with that?
Yes.
So 6, 0 is right there. 0, 3 is right there. Going back to the actual original inequality, I see that we did have equals, so I'm going to draw a solid line through those 2 points. Let's see here. And man, but it said, oh, we need to pick a test point again. So again, let's use 0, 0. If I plug 0, 0 in here, 0 plus 2 times 0 less than or equal to 6, 0 plus 0 less than or equal to 6, 0 less than or equal to 6. So 0, 0 is a solution to the red, so it's down there. All right, so where's our solution of the two? Where do they intersect? Well, let's go to green. They're going to be right here. Okay, so it's below the red and above the black. All right with that?
Yes.
Okay, so I want to go, we've got time for about one more problem. So I want to go back to WebAssign, which I think I closed up. Yeah, so let's get rid of that. And we'll go back in here. And okay. Let's see. And 4.5. And let's take this one here. Okay, because now, can everybody see problem number 5 from WebAssign on your screen?
Yes.
Okay, good,
Yes.
good. Okay, so I've got y is greater than 2x minus 3, and y is greater than or equal to negative x minus 3. Okay, I'm going to go back to my regular screen because, again, my goal is to make you completely dizzy by switching back and forth all the time. Is it working? Okay. So both of these are already in slope-intercept form. Okay. If they weren't, I could put them in slope-intercept form. If I wanted to use ordered pairs, I could do that. But what I want you to see is how you go about doing this on WebAssign. So my first one, I already know that the slope is 2 and the y-intercept is -3, right? Yes. Right, Mr. Mayo?
Yes.
Okay, good. I know I have too much fun. I'm sorry. Actually, no, I'm not sorry at all. All right, sorry, not sorry. Reese's Peanut Butter Cups. Okay, so gotta have a blue line. The y-intercept is negative. Oh, look at that. My graph, my scale is in 2s. So I gotta pay attention to that. Okay, so -3 is gonna be right there. I'm gonna go up 2 and over 1. Now, if I go up 2, that's going to take me there, and over 1 is going to take me right there. So what should my ordered pairs be? Well, okay. Let's go back here again, just to make sure. So my ordered pairs, I would have what? If x is 0, y is -3. I went up 2 and over 1. If I go over 1, that means my x is 1. If x is 1, what's y? Oh, wait. Yeah, if x is 1, what's y?
Would it be -4?
Let's
-2?
see here. Let's see. This opens a can of worms, doesn't it? If we look at this, and we have x is 0, y is -3. If x is 1, oops, y is -1, isn't it?
Yes.
Okay, so back over here. Yeah, why did they have to use a different scale? It would have been so much nicer if they hadn't. So I've got 0, -3, and 1, -1, okay? So all I'm doing is verifying that, yes, even with this tricky scale, I got correct points. Oh, but it says y is greater than 2x minus 3. So I need for this line to be dashed. Okay? Now, here's the deal. If I was just graphing y equal or y greater than 2x minus 3, I would go ahead and fill this piece over here. But I've got a second line to do, and that's why whenever I click on the fill, that little thing comes on up there telling me I'm actually going to wait to do the fill. Okay? Now, let's take the y is greater than or equal to negative x minus 3. So what's my y-intercept here?
-1.
No, it'd be negative 3.
Oh, I'm sorry. Yeah, -3.
Okay. The slope is -1. So I'm going to go down 1 and over 1 to right there. Okay. Now, is this line solid or dotted?
Solid.
Solid. Okay. So the first inequality, the dotted line, we determined that we wanted to shade on the left side of it. Okay. So that would be over here. The solid line, it's y is greater than or equal to, we want to shade above it. So where is the intersection of this and this? It would be right there. Do you see how? So I had to kind of wait till I had both lines before I graphed or shaded. So for the dotted line, I would have shaded this part, and for the solid line, this part, and so I just picked that where they overlap. Okay, our time's up, so I'm going to close shop here and stop